here we go. First one right here. Functions and relations. Definition. Relation. A set of ordered pairs where you have x, y. X is called the domain, y is called the range. Definition. Function. A correspondence from one set, the domain, to the other set, the range, such that each element in the domain corresponds to exactly one element in the range. All right, so first question I have for you, and I know you guys all have done functions before. Basically, remember, a single x goes to a single y. Y, there's no restriction on y. You can have the same y, you can have different y's, no one cares. However, the domain, you can only plug in the domain one time. You should get one range out of it. Does that make sense? So, is this a function? Yes or no is going to be the question. 1 goes to 1, 3 goes to 2, 5 goes to 3. Is this thing a function? Yes, it is. This will be yes. Okay. What about number 2? 1 goes to 1, 2 goes to 4, 3 goes to -5, 2 goes to -4. Is this thing a function? All right. If you say it's not a function, then you got to tell me why. Right. 2 goes to 4, and remember, in the definition of function, 1x can only go to 1 y. You can go to the same y. We don't care about the y, but you can't go to two. You can't go to 2 different y's. And now I got 2 also going to -4. There's my problem right there. Does that make sense? All right. But then the next thing it leads to is honestly the graph. Is this thing a function? Well, let's take a look at the graph of it. And to be able to graph it, so automatically we're thinking about graphing calculators and stuff, I would solve this thing for y. If I solve this thing for y, I would subtract x squared and divide by 2. That would be -x squared divided by 2, right? What does this graph look like? If I graph this thing, you do not need a calculator to graph this thing. You should know what the graph of this thing looks like. What does it look like? Well, first off, x squared means the parabola, right? What's the negative in front of it mean it's going to do? Reflect across the x-axis, flipped upside down. And then divide by 2 means it compresses it by a factor of 2, or kind of so it shrinks it in a little bit, but it's upside down, so it looks pretty much like that. Is this guy a function? Well, remember, the way you define a function is each x can only go to a single y value. So this x goes to this one, 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 this x goes to this one. So is this thing a function? Yes, it is. But it leads us to this idea of x going only to one y value, leads us to our next little statement down here, which is a great way to analyze something in terms of a graph. You can always tell from a picture of a particular relation whether it's a function or not by something called the what? Vertical line test. Vertical line test says this: if you happen to have a vertical line that intersects a graph more than once, it's not going to be a function. A vertical line will only intersect a function one time. Notice any vertical line you throw in there, how many times does it intersect that function? Once. That's why this guy's a function. What about this guy over here? What is this equation of? X squared plus y squared equals 1. That's an equation you guys should be familiar with. What is it? Equation of a circle with radius 1. X squared plus y squared equals r squared is our standard form of a circle. So this is an equation of a circle. So is this guy going to be a function? Well, we can do that vertical line test thing here. But an example would be, for example, if I plug in 0 in for y. Well, excuse me, let me plug in a 0 in for x. Plug in a 0 in for x. What y coordinates would you get here? Well, that would give me y squared equals 1. What kills off a square? Square root. But anytime you take the square of a number, you always got to take plus or minus. So you're going to get plus 1, you're going to get minus 1. So I've got a single x going to 2 different y coordinates. It really violates that vertical line test. So this answer would clearly be no, it is not a function. But really what I'm doing is something you no doubt have done in many, many classes before, which is the famous vertical line test. So you have exactly 6 seconds to do the next 6 problems. That means, that's right, mathematically, that's 1 second per problem. The question is, are these guys functions? The answer is either yes or no, y or n. Is this guy a function? Yes. This one? No. This one? Yes. Well, what in the world is a no? Yes. What is that? Is it a function?
Yes.
Any vertical line only intersects the graph at one point. So yes. Is this a function?
Yes.
Is this a function? It took more than your 6 seconds, but there you go. Does that make sense? Just because, I mean, yeah, you're right, coming in here, but literally a vertical line will only hit at one point. So there you go. Does that make sense? All right. Again, algebra review. Welcome to Calc 1. Domain and range of a function. Domain, we know is the x values. It's called the input. The range is the output, also known as the y values. So, on this particular graph, again, assuming each hash mark is 1 unit long, so here's 1, -1, here's 1, here's 1, here's 2 up here. I want you to look at this graph and tell me what the domain of this graph is and what the range of this graph is. What's the definition of domain? X values. What about x values that were graphed? Well, we hit -1, and that's a full dot there. So I'm going to, remember, you read a graph from left to right and the x, so I focus on the x-axis. I hit -1, and I go all the way up to what number? +1, right? But that's an open circle there. So do I want to include that point? No. So that would give me, what do I use? Parentheses. Okay? What's the range? It's the only time I ever give you the y coordinates. Only time I ever analyze the y-axis is with the word range. If I ask for domain, if I ask for increase, decrease, later on we'll talk about concavity. Anytime I'm talking about a function, I'm always going to give you describing the graph through the x coordinates. The only time I use the y coordinates is with this word right here. What's the range? So this is, I'm focusing on the y coordinates. What's my range? Well, I hit that point down there, and what point is that? -1. That's a block on -1, bracket there. And what do I go up to on the y-axis? 2, but because there's an open circle, I got to use a parentheses. Does that make sense? All right. What about this guy here? Well, to figure out what the domain and range is, this is the one thing that didn't show up on my little graph, so I'm going to have to throw in some hash marks for you. So here we go. Here's 1, here's 2. I declared that to be 3. Here's -1, here's -2, here's -3, here's -4, assuming it actually comes to that point. All right, here's 1, 2, 3, -1, -2. Just say it's right down there. Okay. So, question for you. What's the domain? What's the range? Based upon the hash marks that I just put on this thing. All right, the domain is from -4, assuming it hits -4 there. That's what I meant to do. -4 because it's a dot, it's a bracket, to 3, and another bracket right there, 3. Okay. What about the range? Well, you got to get your high and your lows on this one, which is -2 is the low, and I hit that point, -2, all the way up to 3. It's the only time I ever use the y coordinates. All right, that's the guy over here. -1, -2, 1, 2, 1, 2, 3, 4, -1, -2, -3, let's say. Okay? What is the domain of this guy? -2 to 2. But do I actually hit those two endpoints, -2 and 2? So I got to use open parentheses. What about the range? The only time I use the y-axis, over here is the y-axis, the only time I use it. And the low point right here is at -3. And do I actually hit -3 because of those open circles? Parentheses. And how high do I go? 4. Do I actually hit the 4 point? Yep, so that'd be a bracket. So it's really easy to do domain and ranges when you got the graph. What are you going to do when you got the functions? Well, there's some classic things in mathematics that you got to remember. First thing, step 1, for rule number 1 in mathematics, you cannot divide by what number? 0. Rule of math, cannot divide by 0. What a big part of calculus is we're going to analyze what happens when we get really close to dividing by 0. What happens to my overall function? That's going to be something that we call limits. The second thing is this. You can't take the square root of what kind of numbers? Negative. You can't take the square root or an even root of a negative number. So you can only take the square root of 0 and positive numbers. Square root of 0 is 0, that's fine. And you can take the square root of a positive number. Square root of 25 is 5, that works great. You just can't take the square root of a negative number or take an even root of a negative number. All right? Other rules of math, logarithms. I know you've had them. We're going to be looking at them again, but it's something you're supposed to have had in your previous math classes and all the many years of math you've had. So logarithms. You can't take the log of a negative number, nor can you take the log of 0. You can only take the log of what kind of numbers? Positive, strictly greater than 0. Does that make sense? Those are your big restrictions on mathematics here. So you see this guy right here? I've got here the square root of 2 minus x. I want to take, what's the domain of this guy? Figure out the domain. What you should do is take 2 minus x and make it strictly greater than or equal to 0, because you can't take the square root of a negative number. So, but you can take the square root of 0 or positive. So you force whatever you're taking the square root of to be greater than 0. Now, help me solve this thing. What's my first move to solve this guy? Well, I'm going to subtract 2 from both sides. Minus x is greater than or equal to negative 2. Now, what do you got to do to get that x by himself? What am I going to do now? I'm going to divide by negative 1. But something should scream at you besides me about dividing by a negative number. So I've got to switch the sign. That becomes less than or equal to negative 2 divided by negative 1 is 2. And that is my domain. Does that make sense? This is set notation. If I wanted to write them in interval notation, that would be negative infinity all the way up to 2, but it's a bracket because I'm equaling it to 2. Does that make sense? That is domain. If I wanted the range on this guy, which I'm basically asking what the domain is, but on this one, if I wanted to know what the range is, you know what you should do? Graph it. Because getting the range is actually, after putting in your domain up here, is really where you get the range stuff from. So you should always graph it. Well, let's do the first one. I'll do that one. But let's graph that guy. This was y equals the square root of 2 minus x. So sliding it up. Y equals the square root of 2 minus x. Close parentheses. I'm just going to do a zoom 6 on it. Well, there it is. Negative infinity, because it keeps on going, negative infinity all the way up to 2. What's the range? 0. This thing keeps on going, so only time I look at the y-axis, it is from 0 to infinity. So the range, you're going to be getting it from the calculator, which is bracket 0 to infinity. This is the domain. Does that make sense? Did I lose you guys anywhere? All right. What about this guy here? What's the domain? First off, let's focus on the domain. Well, this one's real easy. I'm dividing. What's the one thing I can't divide by? So I'm going to take that x plus 2. I'm going to set him equal to 0, which is what I'm not supposed to do because I've got to figure out where that sucker is equal to 0 and omit him. So I'm going to subtract 2 from both sides. X is equal to negative 2. Does that make sense? So what's the domain? Well, basically I'm telling you this. The one number I can't have in the domain is negative 2. So my domain is all real numbers except negative 2. And you can write that out in English. All real numbers except negative 2. That's great. But how would I write that interval notation? This is a web work thing. Negative infinity to negative 2, parentheses, union, negative 2 to infinity. You have to include all the numbers. It starts at negative infinity, you go up to negative 2, but at negative 2 you've got to stop. And I put parentheses around it to show the omission of the negative 2, parentheses from negative 2 to infinity. Does that make sense? Well, what is the range of this guy? Well, this last one I'm going to do with range here, but this is a trick question. You'll see this. This will lead into other questions later. So what am I going to do to this guy? Well, let's graph him. Parentheses x squared minus 4 divided by parentheses x plus 2. And I'm going to do a zoom 6 on it. And there's my graph. What is the range? All real numbers, because it keeps on going up, keeps on going down, right? Nope. All right. This is why the calculator and computers can fool you sometime. Let me just change this up a little bit. I'm going to change my window a little bit, and I'm going to blow this thing up so you guys can see it a little better. So let me change my window. And let's see here. I'm going to go from negative 10 to that should do it. Just changing the x's a little bit. Negative 10 to 6. Now let me blow it up so you guys can see it a little bit better. So there's a little delay in my little system here. So there we go. Let me hit graph. What's the domain? Wait a minute. Maybe you don't see it. The beauty of the computer. Keep going. Do you see it yet? Okay. Wait a minute. Just keep working at it. Okay. Autofocus. Do you see a problem here? There's a hole in the graph. See, the calculator's in connect mode. So if the calculator doesn't see it in connect mode, it focuses on 0, and the original screen was from negative 10 to 10. So it just plots things, randomly numbers from negative 10 to 10, and lights up the little pixels and shows you what the graph looks like. But you see, there was a problem at negative 2. And in its randomness of picking points, it didn't pick negative 2, so it kind of glossed and kind of connected right over negative 2. But once I stuck negative 2 in the middle of my window, I did it from negative 10 to 6, which makes negative 2 in the middle. The calculator saw negative 2 was a problem. And at that problem, what does it do? It makes a little hole. Where's that hole at? Well, I can count hash marks. The hash marks are right here. 1, 2, 3. Looks like about negative 4, right? So you know what the range is on this guy? Well, that you can zoom it back, you guys can see the hole in the graph here. All right. So on this one, the range is actually from negative infinity to negative 4, union negative 4 to infinity. There was a hole at the point negative 2, negative 4. Does that make sense? See, be careful. You're right. At first observation, I agree with you. It looked like it was from negative infinity to infinity. But knowing that when I divide by this at negative 2, there's a problem here. When you have a problem point, it's either going to show up as a hole or show up as something you guys probably know is better as a vertical asymptote. So, but again, just trying to make you guys review some stuff here. Let's just do some more practicing here. But I'm just going to ask what the domain is on these last two. What's the domain on these guys? Well, this first one, I got a combination. I got a square root in the denominator. That's a problem because with square roots, I can't take the square root of negative numbers. And the denominator, I can't divide by 0. So what kind of numbers can I take the square root of? Zeros and positive. But remember, it's in the denominator, so I can't divide by 0. So to do this problem, I got to do a kind of a combination between the two. I got to take that x plus 5 and make it strictly greater than 0. Does that make sense? Because I can't divide by 0, so I want to make sure I omit that. Solving for x, subtract 5 from both sides. X is greater than negative 5, or negative 5 to infinity. We'll take it either way. Mostly web work is going to want the interval notation stuff for you guys. That is my domain. Does that make sense? What about this dude over here? Natural log. What was the rules about logarithms? You can only take the log of what kind of numbers with logs? Positive. So what you're taking the log of, which is 6x minus 3, must be strictly greater than 0, aka positive. Add 3 to both sides. I get 6x greater than 3. Divide by 6 on both sides. X is greater than 1/2. And there's my answer. Or, in interval notation, from 1/2, open parenthesis there, to infinity. Interval notation. Does that make sense? Questions? Let's put plays here. One of the most important things that we're going to be discussing in this class relates to the equations of lines. Now, I know in Algebra 1 and in Algebra 2 and so forth and so on, you guys beat to death lines. So, what do you have to have a line? The first thing you got to have is slope. The standard symbol for slope is the letter M. You may know slope better as rise over run. It's also the change in y with the change in x. In calculus and in mathematics, the symbol for change is the Greek letter delta. Delta y over delta x. Remember, delta stands for change. It's going to be something very important in our calculus concepts. So this is the change in y over the change in x, which is y2 minus y1 over x2 minus x1. Okay? So, first thing we have is a slope for formula. Formula for slope is y2 minus y1 over x2 minus x1, where, just to let you know, x1, y1, and x2, y2 are some kind of given points, because it requires you to have 2 points to have an equation of a line. All right? Now, let's talk about all the forms of equations of lines that you're supposed to have memorized. Well, what are they? The first one is the slope-intercept form. I bet everybody remembers that as the old y equals mx plus b. M is the slope, b is called the y-intercept. Okay? The other one is called the point slope formula. Y minus y, I put sub-0 here, equals m times x minus x0. Where x0 and y0 is a point and m is the slope, called the point slope formula. The general form of equation of a line, ax plus by plus c equals 0. The equation of a horizontal line, y equals b. Now just a motion with your hands, which way is horizontal? Good. All right, you'd be amazed how many people screw that up. This is horizontal, right? Which way is vertical? So x equals c is a vertical line. That would be the up and down motion vertical line. All right. Now I got a question for you. Now these are my big 3 equations here. Which one is the most important? Slope-intercept, point slope, or general form? Which is the most important and why? This is the part that you're supposed to catch in your Algebra 1, Algebra 2 classes, but they're not emphasized by a lot of the teachers these days. There is one that's more important than the others. Which one is it?
General form.
Which one?
General form.
Nah.
I would say slope-intercept.
Slope-intercept form.
Because you can graph a lot easier.
That's true. But that's not the most important one.
Point slope.
That's right. The point slope, the only one left. Let me explain why. Why? The point slope is used when you hear these magic words. Find the equation of a line. It has one purpose in life. The point slope formula has one purpose in life. And that purpose is anytime you hear the words, find the equation of a line. And 99% of the math problems that deal with lines have the first words in that question is, find the equation of the line. And because of that, it has only one purpose in life. But that purpose is the most important. So if I have to give you a problem and say, find the equation of a line that does something weird. Okay, find the equation of a line. What do you got to have? You need the point slope formula, which means you got to have a point and you got to have a slope. It's a place where you start from. Does that make sense? That's why it's the most important, because out of all the problems I give you, 99% of them are going to be find the equation of a line. And in this class, the question is going to be find the equation of the tangent line. We're going to be talking about some calculus stuff with this stuff. where you're going to see it a lot. Okay? The next most important one is the slope-intercept form. It has two purposes in life. The two purposes in life for this guy is, number one, it is used to read off data. That's its number one purpose. I give you the equation. Y equals 3x plus 2. Y equals 3x plus 2. What's the slope? 3. What's the y-intercept? You read off data. It's used to read off data. And you mentioned that the second thing that it does is it's used to graph. Anytime you want to graph it, you want to put it in slope-intercept form. So it has two purposes. But the most important one is the point-slope formula, because before you even start graphing it and reading off data, you've got to find the equation of the line first. That's why this one's more important. Now to go for the general form. What is the general form? What is it used for? It has one purpose, and that purpose is it looks good. It doesn't really have a purpose. It's just really cool when you're printing out a nice textbook type thing to shovel everything on one side and set it equal to 0. It doesn't really have a purpose. Now in linear algebra, we're going to kind of line up a bunch of things together and they all look alike. That's fine. But in reality, it doesn't really have a purpose. It just looks good to put everything on one side. And usually A, B, and C are going to be nice whole numbers, and you want A to be a positive integer. So you manipulate the equation to make it look good. But it doesn't, you don't read it off, you don't do anything with it. It's just a great way of typing the equation in. It has one purpose. It looks good to shovel everything on one side and make all your variables all together and set it equal to 0. But it doesn't really have a purpose. Okay? Obviously, these are important, the vertical lines and horizontal lines, but they're kind of special cases. All right, let's talk about, again, you understand what I'm doing here is I'm highlighting all the things you guys did in your pre-calculus college algebra courses, which is, number one, lines. What are some other things we know about lines? What do you guys know about parallel lines? Parallel lines always have what? Same slope, because they go in the same general direction. So parallel lines have the same slope. So if you have two different equations, they're parallel if the slopes are equal to each other. And that being the case, you have, what's the deal on perpendicular lines? Now, parallel lines have the same slope. What do perpendicular lines have? The concept of the word negative reciprocal, to be fancy with the terms. Negative reciprocal slopes. What's a negative reciprocal? Well, if the slope is 3, the negative reciprocal is negative 1/3. You flip the fraction, change the sign. If the slope is 2/3, the negative reciprocal would be negative 3/2. Okay, and that's the relationship between the slopes, negative reciprocal stuff. And perpendicular means they cross at a 90-degree angle. Again, it's just refresher. But you're going to use this stuff a lot. That's why it is important for me to go over this, because it will not be very long before we start really hitting the concept of lines once again. So let's see if we can practice these problems here. Find the equation of the line. Notice its first fancy words. Find the equation of the line that passes to the point 0, -3, with a slope of -2. Anytime you hear the magic word, find the equation of a line, what's the form that you're always going to use? Point slope. It is the most important. The most important, which is, hold on. All right, there we go. I hit the freeze button. All right, I'm moving again. Okay. Y minus y1 equals m times x minus x1. To be able to use the point slope formula, you've got to have two things. What are those two things? Yeah, don't hurt yourselves. This is math. Math is pretty straightforward. Point and a slope. Remember that. When we start talking about mathematical concepts, a lot of people have difficulty with mathematical concepts because they get confused. And they need to step back a little bit and think about it. Now, remember, mathematicians came up with this stuff. So it's got to be high tech, right? You know, got to remember this. Mathematicians also have to explain this crap to other people. And to be able to explain it to other people, we got to come up with the most simplest terms so people can follow along what we're doing. So what would you call the equation that needs a point and a slope to be able to use it? Point slope. So don't hurt yourselves. All right, so we're going to use the point slope. So I need a point. There's one. And I need a slope. There's one. All right, so here we go. y minus negative 3 equals a slope negative 2 times x minus 0. Literally, it's a substitution thing. And now, where most students will mess this class up, like they mess all math classes up, is be careful of careless errors. You'll notice that I've typed it in y minus negative 3. I'm just trying to show you some things. I know it's plus, but watch your step, because you do stuff, so many steps in your head, you're going to make a careless error. So take your time. The goal is to make an A in this class. So I got y plus 3 equals negative 2x. And then traditionally, I'll be the first to admit to you, the nicest form to put equations in is slope-intercept form. So if I put it in slope-intercept form, I would solve for y, subtract 3 from both sides. My answer is y equals negative 3x minus y equals negative 2x minus 3. There you go. Does that make sense? Look at the next one. Find the equation of a line that passes through these 2 points, 3, negative 2, and 4, 5. Well, again, first thing I got to do is find the equation of a line. I can use the point slope formula. Y minus y1 equals m times x minus x1. And I got to have a point and a slope. What do I have here? 2 points. Well, I got the point part covered. I got way more than enough points. I need a slope. How do I find that slope? Well, we have a formula. Y, changing y over change x. y2 minus y1 over x2 minus x1. I'll declare this to be the second point. This is the first point. So that'll be 5 minus negative 2, watch the careless errors, over 4 minus 3. What is 5 minus negative 2? 7. Minus minus makes it plus, so that's 7. And 4 minus 3 is 1, so my slope is 7. I like to use a point. Now, here's my question to you. Point slope formula. Which point am I going to use? Am I going to use the point 3, negative 2, or the point 4, 5?
Doesn't matter.
Officially, it doesn't matter. Mathematically, it does matter. Which one should you use? I'll use the 3, negative 2. Why? Smaller numbers, less chance of me screwing this problem up. Bigger the numbers, more. If I had a fraction or something rather than one of these points, avoid those guys, because I've seen you guys use fractions and watch you guys screw it up. So, be careful, take your time. Use the one that has smaller numbers. Don't hurt yourselves. All right, so y minus the y coordinate, negative 2, equals the slope, which is 7, times x minus the x coordinate, which is 3. Again, I'll be the first to admit to you this is not a very pretty looking line. But to get it to look decent, you either want to put it in general form or slope-intercept form. I'm going to put it in slope-intercept form. To do that, a minus minus makes it plus. So that'll be y plus 2. I'm going to distribute the 7. Be careful. 7 times negative 3 is minus 21. Subtract minus 2 from both sides. I get the equation y equals 7x minus 23. The equation of a line that passes through those 2 points. Does that make sense? Again, I know you've done, everyone in here has done this problem at least 100 times before you even walked into this class. But we're going to come back and visit this concept of line, so it's very important that we review this. Okay? Now, I don't do all these problems for you guys, so let's pick, let's do number 4. Okay? Number 4 says this: find the equation of a line that passes through the point 2, negative 4, and is perpendicular to this line here. Well, again, find the equation of a line. What am I going to use? Point slope. Y minus y1 equals m times x minus x1. Point slope. I need a point and a slope. What's that right there? Point. Got the point part covered. I need a slope. What do you guys remember about perpendicular slopes? Negative reciprocal. So first off, I got to find the slope of this line. To find the slope of this line, you need to put it in slope-intercept form. But the nice thing about this problem is they went ahead and put it in slope-intercept form for us. Y equals 1/2 x plus 3. The nice thing about slope-intercept form is the first property it has is you read off data. What's the slope of this line? 1/2. So if the slope is 1/2 and I want perpendicular, what would my perpendicular slope be? Negative 2. Negative reciprocal. Flip it and change the sign. Does that make sense? So there it is. Point slope. Plugging it in, y minus negative 4 equals the slope, negative 2 times x minus 2. Y plus 4 equals negative 2x plus 4. distributing to -2, subtract 4 from both sides, and I get the equation. They cancel. I get y equals -2x. Equation of y. Does that make sense? Questions? Again, my focus here, this is a big review chapter. Number 5. Find the slope and the y-intercept of the equation 9x minus 3y minus 3 equals 0. What form is this equation of the line in? This is in general form. The purpose of general form? It looks good. That's it. I want the slope and y-intercept. So what form do I want to put this guy in? Slope and intercept form, the y equals mx plus b format. So I'm going to solve this thing for y. To solve it for y, I'm going to subtract 9x from both sides. I'm going to add 3 to both sides. This cancels, leaving me with negative 3y equals -9x plus 3. Now I'm going to divide by -3. What I do to one side, I do the other. What I do to one term, I do to all terms. Divide by -3. Cancels. And I get y equals -9 divided by -3 is 3x. 3 divided by -3 is a -1. And there is the equation of the line there. But my question is, what's my slope and what is the y-intercept? The beauty of the slope-intercept form is you just read it right off. What's the slope? 3. What's the y-intercept? There you go. Does that make sense? Again, and I know for a lot of you guys are looking at me and getting you're completely bored out of your minds, but you got to remember, I got 40-some people in this class, and the reality is that there's 40-some different backgrounds in here, depending on if you had college algebra pre-calculus last semester, or you had it last year, or you had it 3 years ago, 5 years ago, or 20 years ago. There's so many different backgrounds in here. All right. Classic functions. Classes of functions. First thing we got is something called a power function. For any real number m, the equation y equals x raised to that power m is called a power function. It's x to a power. But m can be any real number. So x cubed is a power function, but so is x to the half, x to the 2/3 power, x to the -1/2 power. Those guys are called power functions too. It's any x to a power. Does that make sense? The powers can be fractions. You can have x to the pi for all I care. That's a power function. Does that make sense? Polynomial, however, is a function of the form y equals a sub n x to the n plus a n minus 1 x to the n minus 1 plus a n minus 2 raised times x to the n minus 2 plus ... times a1 x plus a0. Where here the a's are called the coefficients, and the n has to be a positive integer. So when you have a positive integer, all the powers on the x's are positive integers. You got x cubed, x squared, x. Those are going to be your powers on the x's here. So looking at this definition and just reminding yourself, yes or no? You got 4 questions here. You have 4 seconds. Yes or no? Are these guys polynomial? If yes, put yes. If no, tell me why too. When mark, get set, go. Is this a polynomial? Yes. Is this a polynomial? All right, stop there for a second. Why is it not a polynomial? Square root. We don't do square roots in calculus class. What's the square root also known as? X to the half power, right? And to be a polynomial, the powers on the x's have to be integers. A half is not an integer. It's a rational number. Is 3. Is this guy a polynomial? Yes or no? The answer is no. Why? You got that 2/3. That is not an integer. It violated the rule. What about number 4? Yes or no? Yes, it is. I know there's a 3 on the bottom, but that's just a constant. That means it's a 1/3 out front. You don't care about the coefficients. Your focus is on the powers of x. This is x squared. This is x to the first. So this guy is a polynomial. Does that make sense? All right. And by the way, the AN, this is a typo here. AN should not be equal to 0. That's a typo on my part. Occasionally you'll see me in my notes as we develop these things, come up with little typos, and I'll try to fix them as we go along. So to be a polynomial, the leading coefficient cannot be 0. Otherwise, AN can be 0, and that would have been fine. All right. Again, this is chapter 1.1 and 1.2. They're actually quite large chapters, but they're algebra review chapters. So, all right, here we go. What's a rational function? A definition of a rational function is a function that has a polynomial over a polynomial. Okay? So you notice I have my polynomial forms written out here. You have asymptotes. Asymptotes is the imaginary line that the graph of a function approaches as the function is restricted in the domain or as the function or as it approaches infinity. There are two different types of asymptotes. They are the vertical asymptotes and the horizontal asymptotes. How do I figure out a vertical asymptote? Vertical asymptote is going to occur when you have your rational function. But remember, what are you not allowed to divide by? 0. So when you have no common factors, which means this thing does not factor out. So if you had something canceling, that's okay. That ends up being that hole in the graph thing there. But to be a vertical asymptote, you've got to have no common factors. So no canceling can go on. And it's where you take the denominator and set it equal to 0. This is how you're going to find them. So you take the denominator and set it equal to 0 because you're trying to figure out the points that violate I can't divide by 0 rules. That's how you find a vertical asymptote. Horizontal asymptote. Horizontal asymptote requires you to know what we call the horizontal asymptote theorem. This, in essence, is the horizontal asymptote theorem. To figure out a horizontal asymptote, you focus on this is what's going on as x approaches infinity or negative infinity. And what you do is you look at your degree of the top polynomial, the numerator polynomial, and the denominator polynomial. The degree is the largest exponent, just to remind you. If the degree of the top is less than the degree of the bottom, n is less than m, then you have y equals 0 as the horizontal asymptote every time. This was called in college algebra and pre-calculus algebra 2, also in pre-calculus. This was called the horizontal asymptote theorem. If the degree of the top is less than the degree of the bottom, y equals 0 is a horizontal asymptote. If the degree of the top and the degree of the bottom are the same, or equal, then y equals the ratio of the leading coefficients is your horizontal asymptote. AN over BN. That's the horizontal asymptote. And if the degree of the top is bigger than the degree of the bottom, you don't have a horizontal asymptote. You will have something called a slant, or some books call it an oblique asymptote. Okay? So, let's take a look. We won't do all these guys, but we'll do some of them. Let's take a look at number 3. Take a look at number 3. I want to find all the asymptotes. Well, there's two of them, two types. There's the vertical asymptote and the horizontal asymptote. How do I find a vertical asymptote? What am I going to do? Well, first off, I got to make sure that I have no common factors. Nothing. I can't factor anything out of here. Nothing's going to cancel. To find a vertical asymptote, I set the deno. What does deno stand for? I set the denominator equal to 0. That would be 5x minus 2 equals 0, and I'm going to solve for x. That means 5x equals 2. Add 2 to both sides. Divided by 5. I get the equation x is equal to 2/5. That is the vertical asymptote to this graph. Does that make sense? How do I find the horizontal asymptote? Well, to find the horizontal asymptote, I use the horizontal asymptote theorem. Horizontal asymptote theorem deals with the degree of the numerator versus degree of the denominator. What's the degree of the numerator on this thing? What's that power right there understood to be? 1. What's the degree of the denominator? 1. When the degree of the numerator is equal to the degree of the denominator, then y equals the ratio of the leading coefficients. So y is equal to, what is my ratio of my leading coefficients? Negative 3/5. That is the horizontal asymptote. Does that make sense? Question?
The vertical asymptote, the top line, what is that?
Oh, set the denominator, deno, equal to 0. Deno standing for denominator. I'm abbreviating that. Okay? So you set the denominator, which is the bottom dude, equal to 0, and you solve for x. Okay? So let's do a little more interesting one here. Number 4. How am I going to find that vertical asymptote? Let's see how good you guys are. I have 2, I take the denominator, 2x squared. I can factor out a 2 here. That would, factor out x. That would leave me with 2 minus x. Down here, does this thing factor? That's my big question here. How does 2x squared minus 2x minus 3, does it factor? Oh, you're in trouble now because this is like 7th grade math. Let's factor it. What times what is 2x squared? Otherwise known as anti-full stuff. X, 2x and x. What times what is 3? 3 and 1. But I want to make sure I get a 2 in the middle here. So if I do 2x, if I put a 3 here, that's going to give me a 6. And I put a 1 there, that'll be 5. So that's not what I got here. But if I put a 3 here and a 1 here, what do I got? If I put a 3 here and a 1 here and I pull it back out, I'm going to get a 3, and it'll be a difference between 2 and 3, which is 1. Got a problem here. Thing doesn't factor. What are you going to do if it doesn't factor? What major formula do you know, being this is a quadratic, that takes polynomials and sets them equal to quadratic sequence? Oh, thank you. The quadratic formula, right? What is the quadratic formula? When thing doesn't factor, you got to use quadratic formula. And that's going to come back and haunt you in this class as well. What is my quadratic formula? What's the formula? Negative b, let's all sing along here, plus or minus the square root of b squared minus 4ac all over 2a. What's a in this problem? 2. B is negative 2. C is negative 3. Plugging it in, negative 2 plus or minus the square root of negative 2 squared minus 4 times a, which is 2, times b, which is negative 3, all over 2 times a, which is 2. Oh, sorry, I'm off the page there. Let me blow it up so you guys can see it in the back there. Negative 2 is 2 plus or minus negative 2 squared is 4. Negative 4 times 2 times negative 3. Well, negative 3 times negative 4 is positive 12 times 2 is 24 all over 4. 4 plus 24 is what? 2 plus or minus the square root of 28 over 4. I got a question for you. How many vertical asymptotes does this thing have? 2. What are my vertical asymptotes? X equals 2 plus the square root of 28 over 4, and x equals 2 minus the square root of 28 over 4. Now I'm doing this for web work purposes. Web work will completely take these answers. However, if I was doing a multiple choice test, you wouldn't see these answers on there because you could clean up that square root of 28. How can you clean up the square root of 28? What is the square root of 28 also known as? What's 28? Break it down. 4 times 7.
14 times.
I see 14 times 2, which is also known as what? 4 times 7, right? What's the square root of 4? Okay, so you can pull the square root of 4 out. That's 2 square roots of 7. Square root of 28 is also known as 2 square roots of 7 is my point. So you would possibly see something like 2 minus 2 square roots of 7 over 4, and you can factor out a 2 and cancel it. You can do lots of canceling on this thing. But in terms of web work, they would accept this. If I wanted I probably should show you this, guys. If I wanted to clean these guys up, let me slide it up here so I can clean it up. If I have x is equal to 2 plus or minus the square root of 28 over 4. Square root of 28, that's 4 times 7. Square root of 4 is 2. So this is 2 plus or minus 2 square roots of 7 over 4. What do you have in common in that numerator? A bunch of 2's. So factor out the 2, you're left with 1 plus or minus the square root of 7 over 4. Now only through strict multiplication division do things cancel. 2 goes into 4 how many times? 2. So x is also equal to 1 plus or minus the square root of 7 over 2. And there are 2 vertical asymptotes here, the plus 1 and the minus 1. Just a little algebra cleanup. Because a multiple choice test, this is how they're going to write the answer. They're going to clean it up as much as possible, just to practice you guys doing that. One last thing on this particular one, I want to do the horizontal asymptote. What's the horizontal asymptote? Well, what's the degree of the numerator? 2. Square the denominator, 2. They're the same again. So what would the horizontal asymptote be? Watch your signs. All right, so it's the leading coefficient. It's -1 over 2, -1/2. That's my vertical asymptote. Does that make sense? Again, no doubt you have seen this stuff before. It's just been a while. So good review. All right, and of course, again, this first little packet's quite long, and I'm running out of time here. But again, most of this stuff is review, so I can't do it all for you guys, especially on 5.2, and I was going to jump into 5.3 today, but this is a good way to stop because I got a feeling there are going to be a bunch of students adding this class before too long. All right, but I want you guys to go over this thing and remind yourself of your trig functions. Sine, cosine, tangent, secant, cosecant, cotangent, and all the information this needs. So finish up second.